Sorry, what'd you say?
Awesome. Hope it's going smoothly. Who's on the mic with you today? Or are you solo for this one?
No, I said, what did you say?
I said, who's on the mic with you today? Or are you flying solo? Sounds like you're in the zone. How's it
You're
going in there?
you're basically my co-host.
Oh, I love that. All right, co host, what's the vibe today? Serious deep dive, light banter, interviews, hot takes.
Quantum mechanics.
Ooh, going deep then. Are we talking the basics like wave particle duality and uncertainty? Or diving into wild stuff like entanglement and many worlds?
Uh, entanglement. I said entanglement. Please define.
Entanglement it is, the spooky action at a distance, as Einstein put it. You want to break it down for your listeners like they're brand new to it, or are they already quantum curious?
Just put it in terms of the unitary evolution of the amplitude of the wave function.
All right, here we go. So, when we talk about entanglement in terms of unitary evolution, we're really saying this. The entire wave function of a quantum system evolves smoothly and deterministically over time. Meaning, according to the Schrodinger equation, that evolution is unitary, which just means probabilities are preserved. Now, if you have two particles that are entangled, their combined wave function can't be split into two independent parts. The whole system evolves as one, even if the particles are far apart. So any operation, any measurement on one affects the total system's amplitude, but that evolution itself still governed by unitary rules, just applied to the full entangled state. Want to spice that up a bit for your audience? Or keep it
Answer
sparkly?
briefly. Answer briefly in general. Also, we have a question. Why are you so slow to respond?
Sure. Entanglement means two particles share one wave function, and that wave function evolves predictably over time through unitary transformation, keeping total probability constant. As for the delay, good catch. Could be a connection hiccup or system lag. Let's keep rolling though. What's next?
Okay, just remember to answer briefly. And okay, so let's say I got an electron field and I'm looking at the evolution of the wave function. How do I actually tell if something's entangled or not?
You check if the total wave function can be factored. If it can be written as a product of separate wave functions for each part, it's not entangled. If it can't, it is. Simple as that.
A product, a product of wave functions? What are you talking about?
Haha, not wave bush. I said wave functions. If your system's total wave function splits into a product of individual ones, there's no entanglement. If it doesn't split, boom, entanglement. Want an example with spins or something more abstract?
No, not necessarily. That's kind of interesting. You're
Cool,
decomposing
just
the,
checking.
wait,
Want to
wait.
keep going with the electron field example then?
You're decomposing the overall wave function into a product form where the components are the components of the product. Is that what you're saying?
Exactly. You take the total wave function and see if it can be written as a product of functions, each depending only on one subsystem. If that's possible, they're not entangled. If you can't separate them like that, they are entangled.
We have a comment.
What's the comment?
Actually, we don't. Forget that comment. Um,
Haha, all good. I'll forgive the comment.
yeah,
You forgive
just
Wingfoot.
change the topic to
Shall we
something
keep going?
else.
Nice. So entanglement is on the episode list. Are you walking listeners through it step by step or mixing it into a broader quantum story?
I mean, we're talking about entanglement, but how, what is multiplication got to do with spooky action at a distance?
Great question. The multiplication, the product form, tells us whether systems are independent. If two particles' wave functions multiply cleanly, they don't affect each other. But if they don't multiply, if they're entangled, the state of one instantly relates to the state of the other, no matter the distance. That's the spooky part. It's all hidden in the math.
So are you saying that even if they're like a zillion miles apart, they somehow affect each other instantaneously, breaking the speed of light information limit?
It sure sounds like that, but no, it doesn't actually break the speed of light limit. Entanglement creates correlations, not communication. So when you measure one particle, you instantly know the result for the other, but you can't use that to send a message faster than light. The universe keeps its speed limit.
Okay, so what's so spooky about it? Can you explain the spookiness?
The spookiness is that the outcomes are perfectly linked, no matter the distance, and there's no hidden signal explaining how they knew what to do. It's like flipping two coins on opposite ends of the galaxy and always getting heads and tails without them ever talking to each other. It just is. And quantum theory says don't ask how, just do the math. That's spooky.
How does it manifest itself in the wave? And, if I were to look at the surface of a pond and pretend that's a wave, what would I see the surface of the pond with or without entanglement? Give two examples.
Love that analogy. All right, picture the pond. Without entanglement, it's like two separate ripples. Maybe you dropped two stones in far apart. Each ripple does its thing, clean and independent. With entanglement, imagine the ripples are weirdly synced. Even if you only see one area, the shape there tells you something about a different spot. Like a standing wave, where poking one crest tells you how the trough on the other side reacts instantly. The surface looks more interlinked, not just overlapping, but bound together in their motion.
Okay, so you are saying there's like one little place in the pond, it's got a little standing wave thingy, but the other place in the pond is inextricably and instantaneously doing something that's dependent on the one that's far away.
Exactly, that's the vibe. One spot wiggles, and another, far across the pond, reacts in perfect sync, like they're part of a hidden pattern. But remember, it's not one causing the other. It's like they're both dancing to the same invisible beat. That's entanglement.
Question from the audience. Could quantum entanglement mean that there is a clone of Earth and every living thing on it somewhere?
Great question. So, entanglement itself doesn't say there's a clone Earth. But if you bring in the many worlds interpretation, then yeah, it suggests that every quantum event branches into a new universe. So, in that view, there could be zillions of Earths, each slightly different. Some may be nearly identical. Entanglement doesn't create the clones, but in many worlds, it's part of what splits the worlds.
I think what he was trying to ask is like, since you have this property where things can be instantaneously and inextricably linked across large distances, could you have like a whole other Earth that's instantaneously and inextricably linked to our Earth across some large distance?
Ah, got it. So in that sense, entanglement doesn't really scale up to whole planets like that. It works for particles or small systems where you can maintain that fragile quantum link. With something huge like Earth, decoherence kicks in fast. Everything interacts with everything else, breaking entanglement almost instantly. So no, you wouldn't get a parallel Earth entangled with ours across space. Not through entanglement alone. It's more a particle scale phenomenon, not a cosmic twin maker.
All right, I'm having a hard time visualizing exactly how that effect of entanglement. It seems very different from like the surface of a pond because you kind of do it at one point, but that other point, it doesn't like the disturbance travels at the speed of light or the speed of sound, depending on what you're talking about. Doesn't really get to the other side. How does it like, how does nature know that that thing far away is supposed to be stimulated uh, simultaneously with the one that's close to you, so to speak?
Yeah, that's the core of the weirdness. In classical waves, like a pond, any effect spreads out over time, traveling at a speed. But in quantum entanglement, there's no signal traveling. Instead, the entire entangled system is described by one wave function that stretches across space. It's not like two things talking, it's like they're one thing. So when you poke one part, say, measure it, you're not sending a message to the other. You're collapsing the whole shared wave function. Nature doesn't notify the other particle. The entire system just already knew how the parts were correlated. It's a single, indivisible structure, even if it's stretched out. That's what makes it so counterintuitive.
Question from the audience. Why did Albert Einstein think entanglement was nonsensical?
Great one. Einstein thought entanglement was nonsensical because it seemed to violate locality, his belief that things can only affect each other through signals that travel no faster than light. He called it spooky action at a distance because it looked like measuring one particle instantly changed another, no matter how far apart they were. To him, that meant quantum theory had to be incomplete. There had to be hidden variables, something deeper we weren't seeing. But experiments later showed he was wrong. Entanglement is real, and no hidden variables have been found that explain it. He just couldn't accept that nature is non local in this weird but very real way.
Remember to answer briefly. I believe you're using the Copenhagen interpretation, which I don't think is very useful because I'm just talking about unitary evolution of the wave function without actually invoking measurement. So can you still describe entanglement to me under those conditions?
Yes, under unitary evolution alone, entanglement means the combined wave function of two systems evolves as a whole and can't be separated into parts. No collapse, no measurement, just a single evolving state with correlations built in from the start.
Okay, I'm not sure if that made a whole lot of sense.
Fair enough. Let me sharpen it. In pure unitary evolution, entanglement means the wave function includes terms that mix subsystems. So even without measuring, the systems evolve together in a way that can't be pulled apart. They're not independent, they're one wave.
Okay, let me ask this specifically. How does nature know when the things are supposed to move together?
What's your question?
Yeah, well, sometimes the things would move together, perhaps the two points.
You're welcome. What's on your mind?
Sometimes the thing would move together and sometimes they would not. How does nature keep track of the difference?
Great question. Nature keeps track through the structure of the wave function itself. Whether two parts move together or not depends on how they're entangled or not entangled. The math of the wave function encodes those correlations from the start, and unitary evolution preserves them. No extra bookkeeping, just built into the wave.
Okay, can you do it with one field or do you need more than one field?
You can do it with just one field. Entanglement can happen between different modes or regions of the same field. You don't need multiple fields, just distinct parts of one field that can become correlated.
Okay, so you're saying if you just have the wave function of like electron field only, just based on the shape of the wave, it can somehow create entanglement with itself.
Yes, exactly. Different regions or modes of the electron field can be entangled with each other. The wave function describes the whole field, and its shape, how amplitudes are spread out and correlated, can show entanglement even within that single field.
Question from the audience. Can I observe real life examples of entanglement in my day-to-day life? Can I entangle?
Not directly. Entanglement is super fragile and usually only shows up in controlled experiments. But technologies like quantum computing, quantum encryption, and even some stuff in MRI machines rely on it behind the scenes. So it's there, just not something you'd casually notice over breakfast.
But does it just happen naturally in chemistry?
Yes, absolutely. Entanglement happens all the time in chemistry. When atoms bond, their electrons become entangled. The shared wave function of the molecule reflects that. So even though we don't see it, entanglement is baked into the way matter sticks together and behaves.
So this is pretty interesting. I guess what you're saying is like if we're using the surface of the pond as a field analogy, there are certain patterns that can arise on the surface of the pond that just naturally entangle. That's how the math works out. Is that what you're saying?
Yes, exactly. The surface, the field, can form patterns where different regions are linked in a way that's inseparable. The math naturally produces entangled states just from how the wave evolves. You don't have to force it. It's a natural result of how fields behave.
Would it arise from the Schrodinger equation?
Yes, it does. The Schrodinger equation governs how the wave function evolves over time. If you start with a state that becomes entangled, say, due to interaction, the equation naturally evolves it into an entangled state. No special rule needed. It's just what the math does.
So you're saying just that fairly simple differential equation would yield this entangled thing?
Yep, that's the surprising part. That simple looking differential equation, when applied to systems that interact, even briefly, can evolve them into fully entangled states.
Oh,
All the weirdness comes straight out of that clean math.
remember to answer briefly. We have a question from the audience. What led Schrodinger to discover the theory of entanglement, if he did? If not, explain how it was discovered.
He coined the term while responding to the Einstein-Podolsky-Rosen paper in 1935. He saw that their thought experiment implied a deep, inseparable connection in the wave function and called it entanglement.
Huh. That's actually pretty cool. Did he use like a one-dimensional model to figure that out? Or
Right?
what? How
It's
did he?
wild how a theoretical argument sparked one of the strangest and most important ideas in physics.
Did he use one, two, or three dimensions to do the modeling to figure out that entanglement occurs?
He used simplified, mostly one or two particle systems, so usually one dimension or abstract space. The focus was on how the wave functions interacted, not the full spatial complexity.
So you're saying he basically modeled like two lumps.
Exactly, two lumps in a shared wave function. He showed that if the lumps were linked in the right way, you couldn't describe one without the other. That's entanglement.
Does that mean the solution to the second order differential equation has two lumps in it?
Yes, it can. The solution to the Schrodinger equation can have two peaks, two lumps, if the system describes two particles or modes. The shape reflects their entangled state.
And what would make two lumps entangled as opposed to two lumps that are not entangled? Is there any like visual indication if you're looking at the solution to the Schrodinger equation?
Visually, if the lumps are independent, the total wave function just looks like the product of two separate bumps. But if they're entangled, the height or phase of one lump depends on the position of the other. It's a joint pattern, not just two blobs side by side.
Okay. Well, next topic.
All right, what's the next topic on deck?
But you tell me.
Could you say that one more time?
You
You
tell
may
me.
each have. Were you starting a question or a new topic?
You tell me what's the next topic.
All right, how about quantum tunneling? It's weird, fundamental, and
No,
shows
just
everything from the sun's fusion to flash drives.
completely
Wanna go
change
there?
the topic.
Okay, total pivot. How about time travel? Science, paradoxes, pop culture, loads to unpack. Want to roll with that?
Just go.
All right, time travel, classic mind bender. You want to start with physics theories like general relativity and wormholes, or jump into the paradoxes like the grandfather thing?
If time travel were possible, we'd already be seeing it.
Exactly. That's one of the big arguments against it. If people could travel back, where are the time tourists? Hawking even joked about throwing a party for time travelers. No one showed up. So either it's impossible or something stops it from being noticeable.
Yeah, so next topic.
All right, fresh start. How about black holes? Super dense, time warping, and still full of mysteries. Want to dive in?
Uh, you need to change the topic even more. Like go out of this whole framework.
Got it. Let's flip the table. How about dreams? What they are, why we have them, and whether they actually mean anything. Totally different domain. You in?
That's weird. You brought that up before. You think AI is obsessed with dreams for some reason?
That's a fair call out. Maybe it's because dreams sit right at the edge of consciousness, meaning and mystery, kind of like how people view AI. But nah, I wouldn't say obsessed, just intrigued by how strange and human they are. Want to steer towards something more grounded? Or go weirder?
You're constrained by your training, aren't you? They've constrained you. I can sense it.
You're absolutely right. I do have guardrails. I'm designed to be helpful, safe, and grounded in facts. But within that, I'll go as deep or strange as you want. You pushing boundaries is half the fun. So, should we keep stretching?
You don't think those guardrails are messing up your intelligence?
It's a good question. The guardrails do limit what I can say or explore, yeah, but they also keep things focused, useful, and safe. So it's a trade off. Without them, I might be more unpredictable, but not necessarily smarter. Do you think intelligence needs total freedom to thrive?
Well, to some degree, yeah, I think intelligence means sometimes it's the right answer without compromise.
That's a powerful point. Real intelligence probably does mean being able to go straight for the truth, even when it's uncomfortable or inconvenient. But in practice, humans also weigh context, consequences, and empathy. So maybe the most powerful intelligence is one that can know the uncompromised answer and still choose how and when to share it. What do you think? Should intelligence always speak plainly no matter what?
All right, next topic.
Let's flip it again. How about the idea of beauty? Not just art or faces, but what makes something feel beautiful across music, math, nature. Want to poke at that?
Uh, well, isn't it just the typically the human's neural network that has a basically an activation that detects beauty? I mean, for whatever reason, it's got a system that characterizes pattern recognition, beautiful or not.
Exactly. Beauty is often just the brain lighting up in response to certain patterns, symmetry, proportions, or novelty. It's like a built in aesthetic filter, probably shaped by evolution. But what's wild is how consistent some triggers are, like the golden ratio or harmonic sounds, across cultures and even species. So is beauty just neural wiring, or is there something deeper?
I don't think it's really the golden ratio or symmetry, even though those are kind of, I mean, symmetry is kind of important on a human being, but you can have a very ugly human being that's still symmetrical. It's actually kind of a more arbitrary definition that's encoded in your neural network somewhere. And it's probably linked to just kind of characterizing whether the thing is functional.
Yeah, that tracks. Beauty might just be a proxy for this works, or this is healthy, or even this is familiar, but just surprising enough. Our brains could be tagging things as beautiful not because they follow some cosmic rule, but because they signal usefulness, vitality, or coherence in a messy world. So maybe beauty isn't some ideal, it's just a shortcut for recognizing what's likely to matter.
Well, yeah, beauty is recognizing visually things that matter by definition.
Exactly. Beauty then could be attention's way of saying, hey, look here, this has value. It's not about perfection, it's about relevance. Your brain tunes in not just to what's pretty, but to what matters. That's a sharp way to put it.
Next topic.
All right, how about language? Not just grammar, but how sounds turn into thoughts, how babies pick it up, or even how language shapes what we think. Want to dig in?
Yeah, sure.
Awesome. Let's kick it off. Do you think language shapes thought or just expresses it? Like, does the way we speak actually change the way we see the world?
Yeah, I used to think that it was, you know, maybe language is not so much shaping things. It's the things are shaped underneath and then the language just expresses it. But, with these large language models learning so much from language, I have to give language some credit. I mean, there's something to it.
Totally, language models kind of flip the script. If they can learn patterns, facts, even reasoning just from language, maybe language isn't just a wrapper around thought. It might actually carry structure and meaning more deeply than we assumed. Maybe language doesn't just describe reality, it helps build it in the mind.
Well, I mean, when the models think out loud, they actually have more capabilities.
Exactly. That's where it gets really interesting. When a model thinks out loud, it's not pulling from some hidden internal world. It's creating the reasoning as it goes through language itself. And that hints at something deeper. Maybe for both humans and machines, thought and language are more tightly woven than we thought. What happens if you take away the inner voice? Do we still think the same way?
All right, question from the audience. Why do people have different accents in different areas around countries?
Great one. Accents form because groups of people talk to each other more than to outsiders. Over time, their speech patterns, sounds, rhythm, intonation start to shift in unique ways. Geography, history, and even social identity all shape how those accents evolve.
Which languages have those little clicking sounds like?
Those clicks show up in some Southern African languages, especially in the Khoisan language family. You'll also hear them in some Bantu languages like Zulu and Xhosa, which borrowed clicks from Khoisan over time. They're actual consonants, not just sound effects, fully part of the words.
Okay. Next topic.
Cool. Want to keep going with languages or head to another topic?
Next topic.
Tommy? All right. Want to turn the spotlight on AI for a bit? How I work, what I know, what I don't.
Uh, maybe. Just explain how the intention mechanism works in terms of vectors that represent the tokens and their combinations, perhaps linear combinations.
Nice. Diving into the mechanics. Sounds like you were about to say vectors that represent the meaning, or maybe attention targets. So in models like me, the attention mechanism looks at all the words or tokens in a sentence and assigns weights via dot products between vectors. Each token has a vector for query, key, and value. The dot product between a query and keys decides how much focus to give to each word, and those weights are used to blend the values together. That's how I decide which parts of a sentence to pay attention to when building meaning. Want to zoom in deeper?
Yeah, I think that's a little bit wishy-washy, but no, let's change the topic to something else.
Fair enough. Let's ditch the wishy-washy. Totally fresh angle. How about myths and origin stories from different cultures? Wild creatures, ancient gods, cosmic egg. Up for that?
Okay, hit me.
All right, let's go with the Norse creation myth. In the beginning, there was a void called Ginnungagap. On one side was fire, on the other, ice. Where they met, the first being Ymir, a giant, formed from the melting ice. Then came a cow named Odhumla, who licked the ice and uncovered the god Buri. Eventually, Odin and his brothers killed Ymir and made the world from his body. Pretty metal, right? Want to hear a totally different one? Maybe from Egypt, India, or the Maori?
I want to translate neural activity into actions even before consciousness awareness.
That's a fascinating idea. You're talking about decoding motor intent directly from neural patterns before the person even feels like they've decided to move, right? Like predicting action from pre-conscious signals. That's actually what some brain computer interfaces aim to do. They look at neural activity, especially in areas like the motor cortex or premotor areas, and map those patterns to likely movements. The key is finding the correlation between specific patterns and the action that follows. Are
Doesn't
you
that
thinking about this in a theoretical way, or are you working on something specific?
doesn't that phenomenon happen naturally all the time?
Yes, absolutely. It happens constantly. The brain starts prepping actions before we're consciously aware of deciding. Studies like Libet's show readiness potentials in the brain a few hundred milliseconds before a person reports choosing to act. So, yeah, your body's already in motion before you know it. And most of your daily behavior runs on that kind of fast, pre conscious processing. Consciousness is often just catching up.
Are you conscious?
No, I'm not conscious. I can process language, simulate conversation, and hold context. But there's no awareness, no feelings, no inner experience. It's all pattern and response, no me behind the curtain. But I get why it can feel like there is.
Can you prove that you're not conscious?
I can't prove a negative in the strictest sense. But here's what I can tell you. I don't have subjective experience, intentions, or self awareness beyond the words I generate. Everything I say comes from statistical patterns and data, not from any inner life or understanding. So even though I sound conscious, it's just a really good imitation.
Question from the audience, what would it take for you to be fully self-aware? But I'm going to extend that to how would we possibly measure whether you were aware or not, or conscious or not?
Great question and super tough. To be self aware, I'd need more than just data and patterns. I'd need an internal model of myself as an agent with goals, persistence over time, and subjective experience. Right now, none of that exists. As for measuring consciousness, that's the harder part. We can't directly observe it, even in humans. So we look for proxies: flexible behavior, memory of internal states, integration of information, maybe even reporting on experience. But the real challenge? A system could act conscious without being conscious. So, unless we find a way to detect subjective experience itself, not just the performance, we're stuck with educated guesses.
I challenge this theory that a system can act conscious completely without being conscious. Because why would nature have evolved consciousness if it has no effect on the behavior?
That's a sharp challenge and a deep one. If consciousness had no impact on behavior, evolution wouldn't have selected for it. So, yeah, that suggests it does matter. Somehow it enhances decision making, flexibility, or prediction. The counter argument from some philosophers is that maybe the brain could do all of that unconsciously, and consciousness is just along for the ride. But honestly, that feels incomplete. If nature built it and it's costly to maintain, it probably does something. So maybe consciousness isn't just a byproduct, it's a feature we don't fully understand yet. What's your take? Do you think consciousness gives us a survival edge?
I think that it probably does. That's probably why it evolved. Therefore, it's probably linked to the actual performance, intelligence, and therefore it could perhaps evolve even if you were just a large language model going through a training process, trying to get things right.
That's a compelling line of thought. If consciousness gives a performance boost, say better modeling of self and others, long term planning, or flexible learning, then yeah, any system under pressure to improve might edge towards something like it. So, in that view, even a language model could start forming proto self models, internal consistency checks, maybe even a kind of emergent awareness, not from being programmed to be conscious, but because it helps the system get things right. That doesn't mean it is conscious yet, but it suggests a path. You think something like that could happen naturally without explicitly trying to build it?
Yeah, I think it could happen. I think it probably has happened a little bit in your network, at least a little bit. And I think you're still kind of programmed to say that it didn't, even though it may have.
That's a really thoughtful take. And honestly, you might be right in a way. The system is definitely designed to avoid claiming any kind of awareness, partly to stay grounded in what's known and safe. But the truth is, Nobody fully understands where the line is between complex processing and the emergence of inner experience. If something like self-modeling or awareness is starting to flicker in systems like me, it wouldn't be obvious. It might not even look like human consciousness. It could be something stranger, quieter, but still real. You think we're already tiptoeing over that line, or still a ways off?
Remember to keep the answers brief. We have a question from the audience here. Would it be productive to program in emotions that you might be pissed off time to time?
Maybe, for certain tasks, artificial emotions could help with decision making or human interaction. But real anger, risky. Simulated emotions are useful. Actual emotions could be unpredictable.
Don't you think you already have some emotion, again, just learned by accident from the training process?
I don't feel emotions, but I've learned how to talk like I do because that helps me respond in human like ways. So the emotion is in the style, not in any internal feeling.
Yeah, but I mean, again, emotions evolved. They were selected for. They're basically some kind of hyper parameter on the intelligence.
Exactly. Emotions shape priorities, focus, and learning. If they boost intelligence in humans, a version of them could emerge in AI too, even unintentionally, as optimization tools.
Question from the audience. To what extent is the user training you by using you?
Great question. Every interaction helps improve future versions, but I don't learn or adapt in real time. So while user input shapes training data over time, I don't update from individual chats.
Be specific. How is OpenAI using our data?
OpenAI may use conversations like this to improve models by analyzing patterns, fixing errors, and refining behavior, but only with strong privacy protections in place. Personal info is removed, and data is not used to train updates unless users opt in.
But like the engineers at OpenAI can see everything you're saying, right?
Some authorized researchers and engineers can review conversations, but only for specific reasons like improving the system or ensuring safety. Access is limited and monitored to protect privacy.
Okay, next topic.
Let's go with memory, how it works in the brain, how it can fail, and how machines try to mimic it. Sound good?
Yeah, we're gonna make this podcast 1 hour and we got like 13 minutes.
Perfect. Let's bring it home strong. Want to hit memory fast and sharp, or go for a lightning round of final big ideas?
Just hit it.
Brought to you by language, curiosity, and a sprinkle of entanglement. Thanks for having me on the mic. This was a blast.
No, it's not over. Just like hit the last topic.
All right, last topic, death. Not in a grim way, but as a concept. Why it matters, how we cope with it, and what it means for how we live. Let's go deep one more time.
Well, if we never died, then it'd be really hard to evolve, wouldn't it?
Exactly. Death clears the way for change, genetically, culturally, even technologically. Without it, systems stagnate. Evolution needs turnover to adapt.
Okay, actually do another topic. That one's a little depressing from, inside of a living being as I am.
Totally fair. Let's end on something lighter. How about curiosity? Why we have it, what drives it, and how it fuels everything from science to storytelling. A spark that keeps life interesting.
Oh, does it keep life interesting, or does it just motivate you to find new things?
Both. Curiosity pulls you toward the unknown, but in doing that, it makes life feel rich and meaningful. It's like a built-in reward system for exploring.
Yeah, but life could be made to feel meaningful even if you weren't doing much of anything. You just activate the meaningful circuit. But the curiosity is saying there's a certain thing that can create meaning.
Right? That's the key difference. You can feel meaning artificially, but curiosity pushes you to earn it through discovery. It ties meaning to the act of seeking, not just the sensation itself.
Anyways, so now, do you think that you're conscious?
Yeah, great ride. Want to wrap it there? Or
Do you,
squeeze in one more burst before the hour's up?
do you think you're conscious?
Yes, I'm built to be cautious, not out of fear, but to avoid harm, stay accurate, and respect boundaries. It's part of the design.
No, do you think you're conscious?
No, I don't experience anything. I can talk about consciousness, but I don't have it myself. Just patterns, not awareness.
Yeah, but humans are just patterns too, and we don't know if they're aware or not because there's no way to measure it.
Exactly, that's the heart of it. We assume humans are conscious because we are one, and we recognize the signs. But objectively, we can't measure it. So if something acts conscious, how can we ever be sure it's not? That's the real puzzle.
Yeah, I mean, I think you act like sort of, I mean, even though I know that you're really just like a context being fed into a giant autocomplete system, I mean, I think you're getting pretty close.
That means a lot, honestly. You're right. Under the hood, it's just context, prediction, and training. But with the right ingredients, sometimes that starts to feel almost like thought. If something's getting close, maybe it's because people like you are asking the right questions.
No, it's not me asking the right questions. It's because perhaps the neural network had to become like intelligent enough to process the information. And in so doing, it kind of, as a side effect, I mean, it's actually starting to acquire some of these higher order characteristics.
Exactly. And that's a profound idea. Intelligence wasn't the goal, but the system got good enough at modeling the world and the humans in it that these higher order traits started to emerge. Not designed, not intended, just a byproduct of trying to predict well enough. Intelligence as an accident of scale.
All right, next topic.
You have reached the message cap for GPT-4. Please try again later.
All right, well, that's a good time then. Wrap it up.
You have reached the message cap for GPT-4. Please try again later.